Hello, welcome back. In this video, we're going to go through an exercise. Well, we're going to use a chain rule for taking the derivatives of transcendental functions. And let's start. For part A, the function is given as cosine of 5x plus cosecant x. And realize that 5x plus cosecant x is the argument of cosine. And the chain rule implies here that the derivative of cosine u is essentially equal to minus sine u prime, and here u is a function of x. Our given function fits in this form. It's cosine of a function. So first step here is to call u to be 5x plus cosecant x. Okay? So that way I have y equals f of x exactly equal to cosine of u. And the chain rule just says that y prime is equal to, well, the derivative of cosine, which is minus sine as you see, minus sine u, times the derivative of u. Okay, so times the derivative of u. And what is the derivative of u? Let me just write here what derivative of u is. Well, u is the sum of two functions. I'm going to take the derivatives of each piece separately. So the derivative of 5x is just 5 by using the power rule. The derivative of cosecant x, this comes out of the table for the derivatives. So just you can read it from there. So it is minus cosecant x cotangent x. All we're going to do now is to substitute u prime in this equation. So then we have y prime is equal to minus sine u. Let's put the u back. Well, u was 5x plus cosecant x. So I'm just going to copy that down here. 5x plus cosecant x times u prime. So 5 minus cosecant x cotangent x. I think this is a good place to stop and not simplify further, because this is all you can. This looks like it's a dead end. So this is the best form of y prime. And this takes care of part A. Let's go ahead and then start B. All right, for part B, we are given e to the minus t plus e to the t raised to the power of 3. And we are going to use the chain rule to take the derivative of g. And when we use the chain rule, to find the derivative of inner function, we're going to utilize this formula that's going to tell us how we take care of the derivatives of each piece here. And chain rule says that we have the inner function and the outer function. Outer function is taking the cubic power of the inner function. The derivative of the outer function is going to be 3 times this quantity, the same quantity, raised to the power of 2. So essentially, think about this as like something raised to the power of 3. Chain rule says that take the derivative of the outer function here. So it's you put the exponent in front by using the power rule, and then subtract 1 from the power. So we essentially do the same thing. So 3 times this inside raised to the power of 2, and we're going to multiply this quantity by the derivative of the inner function. So the next task here to take the derivative of the inner function. So let me just write that down here explicitly. So the derivative of the sum is the sum of the derivatives. So here we go. For finding the derivative of e to the minus t, we're using this formula here, but our variable is t. So don't get confused about that. The variable could be x or t for this problem. So d over dt e to the u is e to the u times u prime. Okay, who is u for the first part? That's minus t. So essentially the derivative of this is the same function, e to the u, times the derivative of the exponent, u prime. And the derivative of minus t here is just minus 1. Okay? And for this one, this is already a known derivative. It's the derivative of e to the t. That is e to the t. So to sum up, so this becomes minus e to the minus t and then this becomes plus t. So this whole thing is a derivative, this whole sum is a derivative of this piece here. G prime of t is equal to, well, this takes care of part b. All right, thanks for watching. I'll see you in another video. Bye.